This meeting is being recorded.
And exactly opposite is the case with the NMOS. This is in series and this is will be in parallel. Okay. Now we have to draw its equivalent CMOS diagram. So let us start with this. So A plus B, that means we have to connect this in series. Okay, it is A, it is B, VDD. And this C is parallel with this. So this C we have to connect parallel with this A plus B. C. Okay. This is C. Here we will take the output. Okay. Now next thing. Now this is we have completed the PMOS part, right? Now we have to go for the NMOS part, right? We have to go for this NMOS part now. Now here we will draw this NMOS part. Let us start. So in case of NMOS, when there is a plus operator, these are in parallel, right? These are in parallel. So how to do it? This A plus B, it is first we have to draw in a parallel fashion like this. Similarly here also. This is B and this is A. Okay. And this dot we have to connect in a series. This dot we have to connect in a series. Okay. So to this C will come in series. This C. And here it is ground. Okay. And this is what the NMOS structure. This is the NMOS structure. Right. Okay. Now we have to draw the stick diagram. Okay. Just for a second. Hello. Hello. हा.
आता तुम्ही कॉलेजमध्ये 2021 ला जे आपण सिक्युरिटी रिपोर्टचं फोल्डर केलं त्याच्यात किंवा येतं सगळं फोल्डर अपलोड करा की
हो हो करतो करतो. Okay, just a second. हाँ मॅडम.
तुमच्या फक्त तीनच मुलं राहिलेत का फायनल इयरचे?
स्कॉलरशिपचे का?
हा हा
हो हो,
तीनच राहिले
तीन
का?
तीनच राहिलेत आमचे. त्यातले पण एक ए डिव्हिजनचे, दोन माझ्या डिव्हिजनचे.
होय काय? एकच आहेत का तुमचे?
दोन माझ्या डिव्हिजनचे, एक जोशी मॅडमच्या डिव्हिजनचे.
बरं बरं. चालेल.
हा. Okay, now we have to draw a stick diagram. Okay, now first we have to draw the VDD and ground, right? Then this P diffusion, and then green will be the N diffusion, right? And this is the A, this is for B, and this is for third input. Okay, now before we will start here, we have to mark the terminals. Okay, so this is the source, right? This is the drain, this is source, this is drain, this is also drain, and this is source. Similarly, here is also drain, here is drain, this is source, source, this is drain, this is source. Now we have to choose the appropriate input, right? First line will be, we have to choose whether it is A or B or C. Accordingly, depending upon our diagram, we have to do that, right? So what we will do, we will consider this as a, this as a B, and this as a C. Now again, I will consider this is source of A, this is drain of A, this is source of B, this is drain of B. Now see, the drain of B and drain of C is common. So I will consider here drain of C, and this will be a source of C. Now we have to go for the connections. Now this source of A we have to connect here, and source of C also we have to connect. Get it? Now this drain of A and source of B are on the same line, so it is okay. Now drain of B and drain of C, here we have to take the output. This is the output. Okay. Now again coming back to NMOS now. Pull down network. This is A, B, and C. Now here in this case, the drain of A and B, right? This part, drain of A and B. So what we will consider, this we will consider this is a drain of A, this is a drain of B. So but obvious it is source of A and it is source of B. So we will connect this output to this drain. Okay, fine. Now the source of B and drain of B. So we will consider this is the drain of C and it is a source of C. So this source of C, it is connected to the ground, and this source of A, right, and source of B and drain of B, it is common. So we have to connect like this. And this is the output. Now this is your end stick diagram for this circuit. Now based on this stick diagram, we have to go for its actual layout, right? We have to go for its actual layout. Okay. Now, have you understood this? So you have to remember this stick diagram, because based on that we are going to draw the uh, representation of this, or we are going to realize layout using CMOS in the microwave. Okay, so you have to remember this diagram. Okay, now software screen is visible. Software screen is visible. Yes or no?
Yes, sir.
Okay, fine. So first you have to select the foundry, this CMOS 25 rule, open. Okay, now we will start by using the uh, microwave software, and we have to now realize that stick diagram with the help of CMOS, that is a combination of PMOS and NMOS. Pull up network will be PMOS, pull down network will be NMOS, right? Now first in lambda we will choose this. Okay, so you can choose uh, anything. You can, minimum width is 4 lambda is the minimum width. You can place 4 or greater than 4, anything you want. Okay, here it is already given is 10. Okay, here it is already given is 10, so you can keep this as a 5 also, or even 6 also. So I will keep it as a 5. Okay, how many NMOS we will require? 3, for 3 inputs A, B, C, right? So select generate device, keep here. Okay, similarly the case with PMOS, generate device, place here. Okay, you have to simply align the things. Okay, first we will connect this A, B, C part, polysilicon. This is A, B and C. Okay, it is somewhat misaligned. Let me align first. Now it is okay. This first we will connect this A, B, C part here like this. Okay, now this source of A and source of C we have to connect to the VDD. So this is a source of A, this is a source of C, and we have to connect this. It is a common drain of B and C. From this we have to take the output. Okay, and where we have to connect this to the this common drain of the NMOS of A and B, right? Like this, like this. This part we have to make common. Okay, now this is the entire schematic, and already it is a bar of A plus B dot C. So we need not require anything inverter at the output. Okay, now we have to assign the supply and ground. This is VDD, here it is VDD, this is ground, this will be the output Y. So I will name it as a Y. Okay, assign. Then we have to assign the inputs. So here I will assign A, A, Here I will assign B, this B, and the last one will be the C. This is C. Assign. Check if there is if you have violated any design rule. No. So it is, our design is okay. Now we have to simulate this. See, always before simulation you have to check this design rule checker. Okay, you have to DRC, design rule checker. You have to click on this button. If there is any, if you have violated any rule, it will show the errors. If you have not, it will not show anything. Okay, now we have to simulate this thing. Fine. Now here is the case. Now what is the expected output? Right, so you have to tally for each and every. So first we will consider this case. Okay, so this A is 0, B is 0, C is also 0. So for all 0, output is 0. Now second case, right? Now this second case, A is 0, B is 0, and C is 1. That is 0, 0, 1. Output is 1. Now the third case, A is 0, right? B is 1. This third case, A is 0, B is 1, and C is 0. Output is again 1. Next case, A is 1, okay, then B is 0 and C is also 0, output is 1. So you have to check the value for each and every case. Consider this case, this last case, 1 1 1. For all 1, output is 0, right? 1 1, and this also 1. For all 1, output is 0. That means what? Whatever the design, right, it is accurate. So you can go for his VTC curve. Okay, voltage versus voltage. This is I diagram of this. This is voltage versus time. Okay, that means whatever the output we got, it is correct, right? And this is the power, entire power consumption. How much it is? 31.41 microwatt. It is the entire power consumption of our design. Okay, so this is about the first equation. Now see, we have remained with the only two equations, two experiment number 7 and 8, that we will cover in the next practical. Okay, so all of you clear with this?
Yes, sir.
Okay, fine.